Okay, so for this problem, we have to solve for V and I for the following circuit. So the first thing we're going to do is have see the circuit when t is less than 0. So the circuit will pretty much look like this. Our inductor short circuits. When t is less than 0, this was open, so we can just ignore that portion. And then our capacitance leaves behind an open wire. So we have 4 ohms here, 12 volts here. Then we have a current here and a voltage here. So the current passing through the inductor is going to be 0 because this leaves behind an open wire. And the voltage of the capacitor when t is less than 0 or 0 minus is going to be equal to 12 volts. Okay? So, and this is going to be the same current when the second we flip the switch on, because the current passing through the inductor can change instantaneously. So yeah. So now let's draw the circuit when t is greater than or equal to 0. So it looks like the following. This switch is closed, so we can include that part. And then we have our capacitor. So this is 12 volts, 4 ohms, 1 Henry, 2 ohms, 1 over 2 farads, and then we have the voltage of the capacitance. Okay? Now what we're going to do is view the transient response of the circuit. So pretty much what that looks like is we just pretty much ignore the source here. Okay? So pretty much what we're trying to right now find is we're going to try and solve for Vt. And Vt is going to be equal to the transient voltage plus the steady state voltage. Okay? So right now we're going to solve for this part, and then after that we're going to solve for this part. Okay? So, and we have to use this formula pretty much when there is a current source, or when there's some kind of source involved in our circuit. Okay? That, didn't go away after we, flip the switch. Okay. So, right now we're going to be solving for this part. So, the first thing I'm going to do is there's current passing through here. I'm going to have a current passing through here called I1 and I2. So I'm going to call I is equal to, so we know the voltage here is actually going to be the same as the voltage here. So this is going to be V, and it's going to be V over 2 plus the capacitance times the change in voltage over the change in time. This will give you I2. Okay? And what I'm also going to do is I'm going to do a mesh. Okay? So it's 4I plus L di over dt plus 2I1. And something that's interesting about this portion is that the voltage here is going to be the same as the voltage at the capacitance, because the voltage at the capacitance is the same as the voltage here, which will make this the same voltage. So this we can just write as V. Now what we're going to do is do the following. We're going to plug an I into here, and as well as here. So it'll be 4 V over 2 plus C dV over dt plus the inductance times the derivative of this. So it'll be dV over dt times 1 over 2 plus the capacitance, d squared V over dt squared. Okay, and then plus V. And then let's just add FOIL everything out. And this should give you the following. So okay, so LC, that's 1 times 1 over 2, so just 1 over 2 really. Then what else? This is going to be 1 over 2, and this is just 1. So this, so let me just continue writing this. And this is all equal to 0, and I'm just going to times all of this by 2. Okay, there we go. So now we're going to let s equal dv over dt. So it'll be s squared plus 5s plus 6. And now our alpha is going to be this times 1 over 2, so 5 over 2. And our omega is going to be the square root of 6. Okay, so just pretty much the square root of this value. So now we see that alpha is greater than omega. So we're going to use the following formula to find the transient voltage. So to find the S value, it's pretty much going to be using the quadratic formula for this, or we could just use the following formula. So that's minus 5 over 2 okay, and we get the following values. So we get minus 2 and then minus 3. So this is just VTT equals A1E minus 2T plus A2E minus 3T. Now, what we're going to do next is find the steady state voltage, and we'll just add it to this, and then after that we'll solve for A1 and A2. So to find the steady state voltage, let's bring back this circuit, but include the source. And pretty much V steady state is going to be equal to V infinity. So we're going to view the circuit when t equals infinity. So this short circuits, and this becomes an open wire. So we need to find the voltage at this region. So we know the current for this is just going to be, so the voltage source is this. So the current is going to be 12 all over. So this is 4 ohms, and this is 2 ohms. So it'll be 4 plus 2. So it's just 2 amps. So the voltage here is going to be the same as the voltage here. So this is going to be 12 minus 4 times 2, which is 4 volts. So that's your V steady state, and we just add it to this, and that should give you your VT formula. Now let's solve for A1 and A2. So okay, so recall when T was equal to 0, the voltage at the capacitor is 12 volts. Okay, sorry, when T is equal to 0, the voltage at the capacitor is 12 volts. So we're going to plug that here. This is going to be 12. This will be equal to A1. This is gone. This is gone. So plus A2 plus 4. So that's just 8 equals A1 plus A2. Alright, so that's good. Now next we're going to do is take the derivative of this. So dvt over dt equals minus 2a1e minus 2t minus 3a2e minus 3t. And we have to find dv over dt over at a specific point. So what we do know is the following. I is equal to v over 2 plus c dv over dt. So we know what I is when t is equal to 0. It's going to be this value. And we know what v is going to be. It's going to be this value. And obviously the capacitance is just 1 over 2. So now dv over dt, it should be equal to minus 12 when obviously t is equal to 0. So we're going to plug that into here. So minus 12 equals minus 2a1. Obviously when t is 0, this is gone and this is gone. And there we go. Now we have two equations and two unknowns. Now we have to solve for a1 and a2. So a1 should be equal to 12 and a2 should be equal to minus 4. So now we can find vt. It's going to be equal to 12e minus 2t minus 4e minus 3t plus 4. So that's the first bit down. Now I have to solve for I. So to solve for I, it's actually pretty easy. So let's bring back this formula. I is equal to v over 2 plus c dv over dt. So we just plug in v into these. So it's going to be 12e minus 2t minus 4e minus 3t plus 4 all over 2 plus c, which is 1 over 2 farads, times the derivative of all of this. So it will be minus 24e minus 2t plus 12e minus 3t plus 0. And at the end, so this will be 6e minus 2t minus 2e minus 3t plus 2 minus 12e minus 2t plus 6e minus 3t. And then adding everything up at the end, we should get the following. 2 minus 6e minus 2t plus 4e minus 3t amps, and this is for I of t.